Okay, this is Mr. Peterson, and we're going to look at the notes for Algebra 2, section 4.2. And our goal in this section is to learn about graphing rational expressions. Now, in the center of that word, the root of it is ratio, and ratio means fraction. So when I come down here and you see a fraction bar, you shouldn't be surprised. This chapter is all about rational expressions, so you see these fraction bars everywhere. Now, to be a rational function, the y has to be some function of x divided by another function of x. So you have an expression on top, in this first example, 3x minus 5, and you're dividing it by another expression, 2x minus 3. These are both linear, since the x's are to the first power. But on this next one here, you have a linear expression on top, and a quadratic expression on the bottom, and the function f of x is that the quotient of those. It's a fraction with one on the top and the other on the bottom. So this one on top is usually called p of x, and that's what we'll be calling it. And the bottom one is q of x, like that. Now, I did kind of gloss over this really quickly. The q of x, the bottom part, can't turn out to be 0. If you get a 0 in the bottom of a fraction, it's undefined. And you get some really funky looking graphs. They look like maybe this. Here's another one where you get a really crazy looking graph. And one of the features of this type of graph is that you have what are called asymptotes. The p is silent. Say sim in the middle and totes at the back. So asymptotes is how you say that. There can be horizontal ones and vertical ones, and I'm going to draw that here. We actually learned this in the last lesson if you were present for that teaching. So there's a line, an invisible line that goes right through here, and it's at a height of 1.5. These units are hard to see here, so I'm going to mark them. This is 5 up there. And right here at 1.5, I'll try and draw it, is this line here. It's an invisible line. It's not actually part of the graph. That horizontal line is a horizontal asymptote, and you'll see that the feature that makes it such is that this will approach it. It gets closer and closer to it and closes that little daylight right there until it's almost gone. Same thing here. As you go backwards, it gets closer and closer to that line. That makes that an asymptote. This one's horizontal. We'll label it HA. And it's the equation y equals 3/2 or 1.5. Now you're going to see a bigger picture of it down below. There's also a vertical asymptote, and I'm going to try to draw that one. It's going to be right here. And the function approaches that line as you go down forever or up forever. So that one's a vertical asymptote. And I'm not sure where that is, but it looks like, if I can get these things darkened a little bit here, between 1 and 2, so I think that's 1.5 also. So that'll be x equals 3/2. Now, it's part of the purpose of this lesson to learn how to find out where these asymptotes are. So we'll get into that in a minute. Now, you can only ever have one horizontal asymptote, but often you'll have more than one vertical asymptote. And I'm going to show you that this one has an asymptote of y equals 0 right through here. And that's the horizontal one. This thing is getting closer to it. But it's going to have a vertical asymptote right here. And you can see that that function is getting really close to that line. And there's another one right over here. And this one I can pretty much tell is at 3. So x equals 3 is where this one's at. And you can tell that the graph is getting closer to it as you go higher and lower. So we have two vertical asymptotes here. VA at x equals approximately, a little hard to tell, I'm going to say -1 there. And another one at x equals 3. So it's not uncommon to have more than one vertical asymptote, but you can never have more than one you'll have either 0 or 1 vertical or horizontal asymptote. Okay, so I'm going to show you kind of a expanded picture of this part right here of that graph, and you'll see it right here. So our horizontal asymptote, as we said earlier, was y is 3/2. Okay, that's your HA. And this is 2 and this is 1. These are very hard to read here. So the vertical asymptote looks like it's also at 1.5. Let me make that mark right there and go vertical right there, and you can see that the graph, it's red on mine, follows that and gets close to it. So that's x equals 3/2 also. And this picture is just an expanded version of what you're seeing right in here. Now I'm going to teach you something else about horizontal asymptotes by expanding this part right here of the picture, and I have that down here. And what I want to teach you is that sometimes your horizontal asymptote, and that's y equals 0 on this one, sometimes you actually the graph crosses it and then comes up and tucks underneath it. Horizontal asymptotes can be touched or crossed. The vertical ones never are. Okay, so let's get deeper into these notes on page 2, and I'll pick up on the next video for that one.